Hello and welcome to the new episode of the Network and Cisco Packet Tracer tutorials for beginner. Xiaoash is here, and in today's tutorial we continue our routing protocol concepts. Many of you requested for the OSPF routing protocol. So let's begin the OSPF configuration in our previous topology, which we set up the RIP and EIGRP. So first of all, let's review our topology. If you forget what we've done here, we have a LAN 1 with 192.168.10.0/24 network, LAN 2 192.168.20.0/24, which are connected to the router 0 and connect through two WAN link, one WAN 01, slow WAN link, direct connected router 0 to router 1 on the other side of the topology. And we have a fastest WAN link, which are connected router 0 to router 2, router 3, and router 1 with the multi-hub. And finally, in router 1, we have two other network, 192.168.30.0/24 and 40.0/24. So, OSPF stands for Open Shortest Path First and is categorized as a link state routing protocol. We remember the difference between the link state and the distance vector routing protocol. We compare how the RIP and EIGRP works. So as a link state routing protocol, OSPF choose the shortest, or in other words, the fastest link to reach to the destination. The very important question is when using the OSPF. So when you have a multi-vendor routers in your network other than Cisco, OSPF is a great choice. When your network requires segmentation into the areas or zones, you can use the OSPF. You can design the hierarchy IP address for your network for different area or zone. It's very important. And finally, if you want, as a network manager, avoid any proprietary protocol like EIGRP, which is only Cisco understand this. So if you have a Juniper with a Cisco and other vendors, OSPF is a great choice. As a link state, OSPF using the metric. OSPF uses a reference bandwidth of 100 megabit per second links for cost calculation. The formula is simple. To calculate the cost, you have to reference bandwidth divided by interface bandwidth. So let's say, for example, if we have a traditional Ethernet link, since our reference is 100 megabit per second divided by 10, it shows off the cost of 10. So technically, behind the scenes, the OSPF cost is calculated by dividing the 100 million by the bandwidth of the link in bits per second. So 100 megabit per second links got a cost of 1. 10 meg link got a cost of 10, and 1.5 megabit per second link, which is a common WAN link size, is a cost of 64. Okay, so let's start some configuration. Regarding the cost, actually we can set the auto cost reference for a link. Especially modern network have a faster than 100 megabit per second, like 1 gig link. We can use the auto cost reference and increase the cost for all the routers in the topology. So let's go to the router 0 and see what we have previously. Let me make it slightly bigger. So enable the router, show IP route, and as you can see here, we have all the routing is done by the EIGRP. We know about the other side of the network by this EIGRP. Here we go, we can see it, and we enable to ping 192.168.30.10, the PC located on the other side of the WAN link, and 40.10. So we have set up this. If you want to go back to the previous video and recap this, please feel free to practice that. Show run. We have two routing protocol running over this router. We have a RIP and EIGRP. Since the administrative distance of the EIGRP is lower than the administrative distance of the RIP, so the EIGRP works. And remember, the OSPF administrative distance is 110, while the EIGRP is 19, so EIGRP beat the OSPF. So if you want to use OSPF in this topology, we have to disable all previous routing. Is a good idea. RIP is still 120, no harm, but let's do no router RIP. Okay, this one stopped the RIP and no router EIGRP, and we set up the EIGRP process or better say the autonomous system of 1. So now to show IP route, we don't have any routing dynamically learned from the other side. Let's continue on the other side after router 1 and let's take a look. So let's show IP route. I expect that don't see, okay, still run the EIGRP and it still can learn from the WAN link here. So let's do global config and no router RIP and no router EIGRP1. So show IP route, nothing is here, clean. Let's clean up the WAN routers also, router 2. Okay, so as you can see that we lost the neighbor of the EIGRP, so no router RIP, no router EIGRP1, show IP route. Cool, nothing is here, router 3, and here we go, conf-t, no router RIP, no router EIGRP1. So everything is clean now. Let's start to configure the OSPF. One of the important things in OSPF is electing of the designated router, which is a centralized router to update the routes for other routers, send the updates and link state advertisement to all other routers in a network. And we also have another concept called the BDR, which is backup DR or backup designated router. We have a process of election. It's important to choose the proper position for the DR routers. You as a network administrator must take control of your network and put your DR router in center of your network or in a hub and spoke topology. It must be sit on a hub. Since the OSPF algorithm required powerful routers and heavy calculation, so you also have another option to choose your more powerful router as a DR in your network. DR election is based on the router priority. If you don't set the router priority, which is default 1, the router ID come into the picture as a tiebreaker. And if you don't have a router ID set, the highest loopback IP act as a tiebreaker. And if you don't set any loopback in your router, the highest IP address which is set on a router act as a tiebreaker and help to choose the DR election. Let's go back to the router 0. So we set the router ID in this practice. As a network admin, we take control of our network. So the command is router OSPF as process ID, question mark, show the process ID. So process ID 1, and we want to, before advertising network, we choose the router ID in this case. So router ID come in the form of the IP before, and we choose the router ID. If you advertise your network and then select your router ID, you need to restart the OSPF process. So let's advertise the network. We have two connected network, 192.168.10.0. We need the wildcard mask, which is opposite of the subnet mask. So /24 network 255.255.255.0 is equivalent of the wildcard mask of 0.0.0.255. And finally, we need to set the area. In OSPF, all the area must connect to the area 0. In this tutorial, we're using the single area OSPF configuration. So next one, network 20, same thing. It's time to advertise our WAN link 172.16. We have a two WAN link. Let's take a look. 172.16.0.0/30 and 172.16.0.4/30. So /30 means that 255.255.255.252, which is 0.0.0.3. 255 minus 252 is 3, area 0, and other network is 172.16.0.4/30. So let's take a look, zoom in the commands, you quite see. So router OSPF 1 line, which enabled the process. Then we set the router ID, and finally we advertise our networks. 172.16.0.0 and 0.4/30. Look at the wildcard mask. and here we have a /24 wildcard mask, which is 0.0.0.255. So let's do the same setting on the router 1. Global configuration, router OSPF 1, router ID. Okay, let's document the work. We go using the router ID of, let's copy this thing, 1.1.1. okay, we have a router ID of 2.2.2, router ID of 3.3.3, and finally the router ID of 4.4.4 for these routers in our topology. It's very important again to document your works properly. So on the router 1, we set the router ID of 4.4.4. So we're expecting the higher router ID help us to elect as a DR in this topology. Let's see. However, if you have a point-to-point, you no need to the election of the DR. These are some advanced concept. I cannot say advanced, but the concept you need to learn in the OSPF. Let's advertise our network 192.168.30.0, 0.0.0.255 area 0, 40.0, and WAN link we have network 172.16.0.0/30 area 0, and another WAN link is, if I'm not mistaken, 12. Let's double check it. 172.16.0.12. okay, good. So now our neighbor relation of OSPF is came up. OSPF adjacent neighbors, process 1, we have a neighbor with 1.1.1.1, which we set as router ID of the router 0 on serial link of 0/3/0, and the link state is from loading to the full. So we have a loading down. One of the option is, as usual, show IP route is very helpful. Okay, very good. We learned some routing from the OSPF. O for OSPF, you can see OSPF inter area OSPF 192.168.10.0, 192.168.20.0/24 with the administrative distance of 110 belong to the OSPF and metric of 65. So this WAN link is run over 1.5 wish WAN speed, and we can go through the WAN link point to point. So 172.16.0.4 is length, which is this link behind the router 0. Let's take a look at the router 0 status. Okay, our OSPF is forming from the loading to the full, and let's show IP route in this sense. Yes, we learned the OSPF of the network on the other side of the WAN. OSPF 30.0/24, 40.0/24, administrative distance of 110, metric of 65, and we have our neighbor routers. We know how to go there. We also learn about the WAN link, which is connected to other leg of the router 1, which is this WAN number 4. Let's take a look at the show IP OSPF neighbors. It's a very helpful command. It's showing the state of the OSPF is stand in a full and running over which interface, other side address is what, and what is our neighbor ID. So we set the neighbor ID. Since it's a point-to-point link, we don't have a DR election. Let's configure the WAN routers. Go to router 2. So global configuration mode, router OSPF 1, network 172.16.0.4/30, which is 0.0.0.3, area 0. And okay, we have a coming up, and we also have a 16.8 network. Okay, 0.8. Here we go. Let's take a look. Config for your reference. Network OSPF. We don't set the router ID here. So okay, let's show IP route. Let's see what we learned here. Okay, good. We learned some stuff from both sides. It's beautiful. A router LAN 172.16.0.0. Okay, interesting, with the OSPF, which is the slow WAN link we learn about 10, 20, 30, and 40. And as you can see, that is a metric here is 2. So reference metric for the 1 gig length is 100 meg is 1. So we have 1 and 1, which is 2. And 65 plus 1 is 66. So we can reach to the 192.168.30 and 40.0 via 172.16.0.5. So the traffic can travel here, go here, and reach this part. So, okay, let me show you that if we set the router ID after setting the OSPF. So we have to router ID, let's for this one, we're supposed to go with the 2.2.2. Okay, as you can see, the router asks us to reload the OSPF. So clear IP OSPF process. So router get the confirmation, and now we become as a router ID set, show IP OSPF neighbors, and see what we have. Okay, OSPF came up, and we have a full routing with the neighbor 1.1.1, which is 0, router 0. Let's do router 3, global configuration mode, router OSPF 1, router ID is 3.3.3, network 172.16, 0.8, 0.0.0.3, area 0, and network 12. Okay, network 12, here we go. So now we have a full relationship, show IP OSPF neighbor. Let's see how's the status. We learn 2 of our neighbors. Let's make it slightly bigger. Everything can be seen in one line. Cool. So we have a router neighborship with the router ID 2.2.2.2 and 4.4.4, which is R1 and R3 R2 here, and we have a full is considered as a state as a DR for them. So here we go. Now it's beautiful from perspective of router 1. Show IP route OSPF neighbor. Show IP OSPF neighbor, and here we go. So 3.3.3 considered as a BDR is in full state. They're aware of the routing of each other. The topology link state is already loaded everywhere in the network, entire topology. And since the 1.1 is considered as a point-to-point, we don't have any DR election here. So let's take a look at the show IP route, and let's see the final route. We learned from the OSPF about 172.16.0.4, 172.16.0.8, and also we learned about other side of the WAN behind the scenes. So we expected, now we have some ping. Let's ping from the router 192.168.10.10, which is the PC0 here. Okay, some typo, ping, and here we go. Yes, we can reach to the other side. Let's trace route 192.168.10.10. Make sure that we have to take the fast part of the WAN link 172.16.13.9.5.10. 13, go here, .9.5, and reach to the PC here. Let's check from the PC perspective. Go to the desktop. So ping 192.168.30.10. Okay, it's reachable. And let's see, trace it. So 192.168.168.30.10. Okay, we hit our gateway 10.250 on the router 0. Reach to the WAN link, router on the destination, and finally reach to the PC here. So it's a full communication with PC 0 to PC2 and PC3 can be done. Let's try with the last PC here. Yes, we can ping this one also, router 0. Let's see what we learn here. Show IP OSPF neighbors, Yes, we have a full communication, neighbor ID 4.4.4, which is full, point-to-point, no DR election. Router 1, 2.2.2.2. Also, we have a full, in this case, it's the DR and full going on the other side. Let me see. So this, in this case, is a DR for that. And we can show IP route. Here we go. We have 172.16.0.8, 172.16.0.12. Administrative distance 110, metric of 2. Okay, means that if I want to reach to the 172.16.0.8, which is this network, 1 and 2, I can reach here. So no issue, we have a full. So this was the very basic OSPF routing protocol configuration over the topology. I hope it's helpful for you. Please watch, learn, subscribe, and share